Right. Hi, everyone. So I'm Theo. I'm working at Caltech as a staff scientist, and I work for CTF, and I'm developing some of the tools and platforms that they use on a daily basis to get their candidate and all of their data from the CTF, but also different other instruments. So I'll be presenting SkyPortal, which is their Marshall of choice, and we also have it deployed for some other collaborations like GrandMAD, which Sarah mentioned yesterday. So what is it? It aims to be an all-in-one astronomical tool. So the goal isn't to necessarily implement some of the fancy algorithm that you might be using already with some Python package, but to have a tool that merges all of those and makes it accessible with a UI or any kind of user interface through here being a web app. So the backend is all Python with, for those that are interested in it, a Postgres database. And on top of it, we use React, so JavaScript framework for all the front end. So what it tries to allow for astronomers is to discover interesting transients, manage follow-up, perform characterization, visualize all of these results, work as a team, collaborate with different tools, stay up to date with new events, new transients, and also integrate all of the above with this multi-messenger events that a lot of us have been talking about. So for the first, I'll be going through all of these items and kind of just give enough details for everyone to understand what we're trying to do here. So when it comes to discovering interesting transients, of course, we need alert brokers. So at Caltech, we have our internal one called Kowalski, which is for ZTF, Gattini, and soon to be Winter. And in the instance of Grandma, we rely on Think to get all of the transient data. And we allow to filter which candidate you get. And in the case of Kowalski, create automatic annotations. So users are able through a query language. So for those that are familiar with it, it's MongoDB. So it's a non-relational database. So you can use that native query language to both filter through the data and also create annotations with specific data that you're expecting to be able to see from the front end. And then we have a dedicated page for the candidate scanning and vetting. So you can either save the candidate as a proper source, or you can reject it. And on top of that, before the filtering, we add some machine learning classifiers and also spatial cross-matching, all of that good stuff. So I'll be adding a few screenshots just to give an idea of what it looks like and what using it would feel like. So for instance, this is what many scanners go through every morning, which is that candidate page where you're able to apply some basic filters. So that's on top of the filtering that happens in real time to get the candidates. And so you can say, okay, I want all of the candidates that went through in between that date and that date, so usually 24-hour window. I want only those that have not been saved, or those that have been saved, or I don't care about any of that. I only want those that are classified, those that have redshift information, and I want to not see those that have already been rejected. And also on top of that, we can, of course, constrain by whether or not the candidate falls into an event, both spatially and by time. And the result will be a list of candidates. And depending on the filtering that you've put in place, more or less candidates. And for each, of course, thumbnails coming from the alert packet, and also thumbnails that we generate from legacy survey, as well as a light curve, the auto annotations that I mentioned on the right, and some quick information about the source. And then when you're done going through your candidates, saving them, and you want to do follow-up, you want to trigger other instruments to look at it and classify them. So we have a dedicated source page for all of these candidates that you saved as a source. And from that page, you can trigger follow-up from many telescopes. The only constraint being, well, they need to have an API or something to listen to our requests. And you can reassign priority and edit these requests if the instrument allows you to do that from their scheduler, and retrieve the result from the follow-up, which is done either manually, if that's possible from their API, or we also have it automatized for some instruments, so ZTF, Atlas for its force photometry, and ACDM, which puts the results back to the platform. And we also have a concept of observing run where you do not need to necessarily have an instrument that gets your request programmatically, but you can assign targets with priority and generate some quick observation plans to see which one you should observe. And when all of this is done, you can upload new photometry either via the front end or automatically as part of your instruments pipeline. When it comes to visualizing the results, you have all of the good stuff that you would expect from any Marshall. So you have a photometry plot where you can play around with a period, and you also have a spectra plot where you can get all of the different spectra that you have and plot these lines. So this is an overview of what the source page looks like. You could scroll for a while. There's a lot of elements on it, maybe too much. And I know that some people already complained about some platforms having too much data, and I think that we're doing worse here. But so we have all of the thumbnails, the annotations that I mentioned on the right. We have comments. The users are able to leave data here and also attachments. And recently, because this is the ChatGPT era and you don't really have a choice if you want to stay relevant, we have those automated summary that grabs all of the data about the source and creates a short text that summarizes what people have been doing with it. And in that specific instance that we have, which is called Fritz, so it's just SkyPortal with a wrapper and some additional components that you wouldn't have with the normal SkyPortal version. We have access to the full ZTF alert archive from all 3 data streams, and also access to the light curve archive, so the data releases that ZTF uploads online every 2 months, and I think for the next release every 4 months. We have the photometry plot, and on the right here you can see also we have this kind of 2-panel thing with your plotting and most important information on the left, and on the right you have some widgets that allow you. I'll talk about those external analysis soon. And for the follow-up, you have forms where the way that it works is in the backend, we implement different Python classes for each of the different API that are out there. So instruments can just reach out to us because, of course, it's hard to have something that is generic enough to work with everything. But we do provide some generic classes that try to cover most bases. And so for newer instruments, they can also design their API so it matches those requirements. And so users are able to just specify, so the form is automatically generated for each instrument based on the parameters that it has. And so you can provide start date and date and here a mode and of course a priority. And so you get your list of requests. And from there, you can either delete, edit, modify, and retrieve the results for those for which it's not automatic. And right underneath, you can also assign targets to observing runs. So this is the more manual mode that I mentioned before. And one more thing that is not visible in the screenshots is that we made recently a proper difference in between the follow-up request and the force photometry, which was requested by most of the users. And of course, many more things that I didn't include here, but everything else that you would expect from a Marshall. So finding charts, observability charts, access to data from older surveys, centroid plot, HR diagram, archive data, and everything else that you can dream of. When it comes to performing characterization, so SkyPortal as a Marshall is not trying to in-house implement a lot of new classifiers. But what we're trying to do instead is to have a very generic analysis framework where you can deploy your own analysis service. So if you have your own analysis code that takes photometry data or spectra, you can just make it available through an API, and we provide templates for that. And then you can connect it to any SkyPortal instance, send your data, and get the results back. And of course, when you're done characterizing your object, or even if it's just a proper astronomical transient and you want to submit that to TNS, everything is also available through SkyPortal. So you can add these analysis services, and similarly to the follow-up request that I mentioned, basically here you can fully customize. You can say, okay, it takes that parameters, that's a Boolean, takes that parameters, that's an integer or a range, and it will generate the front end based on the parameter of your analysis. So it's a fully flexible framework. An example here, if I go back to the source that I was on before, I can create requests on that form on the right, and then I can visualize the results. So this is running, I think, an FN1A classifier from SN Cosmo, which is a demo example that we have built in the app. And one ambition for that analysis is to implement tools like NMMA, for those that are familiar with it from Michael Coughlin, which are too heavy to run with your own system. So you can, because of that framework, you can offload it to a cluster. So right now it's running on an HPC cluster. Then we have a whole notification framework to stay up to date, which is heavily required for all of the multi-messenger stuff. And so you have fine-grained notification on sources. You can also mark some sources as favorite and be notified anytime anything is added to it. GCN events and user mentions in the comments, and also facility transactions. So every time you get your Spectra back for your follow-up request, you can be notified. And these notifications can come through different channels. So you have email, SMS, phone call, WhatsApp, and also through Slack. And you can constrain some of those, so especially the SMS and phone calls. I don't think everyone wants to be called during the night. So all of those can be constrained either when you are on shift or a specific time range that you specify. You can also program reminders. So let's say you have a source where you want to go back to it. You can program reminders either for yourself or other users saying, okay, please look back at that source in the next 24 hours and repeat that for as many days as you want. So this is what it looks like. So we have this user profile page. And from here, you can define your notification. So here, it's programmed to notify me on sources and my favorite sources, user mention, observation plans that I get to soon, and also GCN events. And in the case of GCN events, we built a framework here where we add tags to these GCN events based on their properties. And so you can filter on this saying, okay, I'd like to be notified only for LVC notices that has neutron star probability superior to 0.1, and if the localization is smaller than 1,000 square degrees. When it comes to working as a team and collaborating, which is important for those platforms, right? Because otherwise, if you don't need to work with other people, you could just have a Python package that does it for you. We implemented groups, shifts, allocation, and within these groups, fine-grained data accessibility. So within one instance of SkyPortal, people can be able to see different data points and make sure that only the people that they want to have access to their data have access to it. So that's an example of the source of the group page. From that group page, you can access via the button on the top left the full list of all of your sources that you save to your group. You can manage your users and their permissions, and you can add new users, invite them to the app. And at the bottom here, this is the addition that we have on that specific instance. You can create those filters within our broker directly from the Marshal. And this is the shift system. Here, well, in the case of ZTF, we made it simple. It's just one shift per week, but you could have shifts every 4 hours, every 6 hours, and people can be added to these shifts. So it's a way to manage and make sure that you always have people available at all times when you're trying to cover this multi-messenger event. And one question might be, how do you manage who can trigger those follow-up requests for those instruments? Where's all of those allocation data stored, all those API tokens? So for that, we have allocation. So for a given instrument and a given group, you can create an allocation that will hold all of those credentials. And now we have a pretty well-defined multi-messenger workflow. So since the beginning of 04, and even before that, we spent some time adding all of the features that we wanted. We've been testing it since the beginning of 04, even though we didn't get any very interesting events. We had the chance to test it on a few of them. So it's a pretty well-defined workflow that gave good results, from getting the notice, triggering the instrument from the platform, getting the candidates back to the platform, then going through them, filtering which ones are interesting, which ones are not, then generating GCN circulars like document, and then uploading them to GCN. So this is what it would look like. So you would head over to SkyPortal, arrive on the dashboard, and you would see the recent sources, top sources, and at the bottom here, the recent GCN events. So you would click on the one that you're interested in. So for example, it could be a GRB, or it could be a significant event. You also have a list dedicated to those, not just through the dashboard. And for each of them, we have a dedicated page with a pretty basic schema that shows you the localization. And on top of that, you can also see the tiles of your instrument, the tiles of the instrument that have been observed. And you can also get sources and galaxies that are within that localization. And all of this can be created on the fly through that form. So we don't pre-generate any of that data. And that's a requirement simply because on that instance, we get new candidates, especially during the nighttime in real time. So we can't really afford to pre-compute things. So it has to be as fast as possible. And other features here that I might show later of creating these GCN, we call them GCN summaries within the app, but they're really just GCN circulars. And we can run packages, Python packages like SimSurvey to assess observability and query some catalogs, and also send the executed observations from your instrument to treasure map or retract those if needed. So I'll give one example. So for that short GRB, we got a total of 5 candidates. And we're able to annotate those, specifically in that context of GCN events, to say, okay, this I would like to highlight it, might be interesting and worth looking into later, or getting some more observations, or reject them. And for each, you can annotate it and add some detail to say, okay, this is because it's a slow rising transient, or because it's an AGN, or it's bogus. And this is what you would get once you're done with your observations. We retrieve the results. This works in the case of the TF, but it could be implemented for any other instrument. Here we do have within SkyPortal a way to retrieve the results, but it's pretty easy to just implement it with any API that provides those observations. So you would get your observations back and upload that to TreasureMap. And also, so that's the summary feature that I mentioned, where you can specify the sky map that you're interested in, the time range for the detections of your sources, and generate these text documents that match what you would like to have in a GCN circular. And also what we have is through Guemopt, which is a package that you can use for observation planning. We have this embedded within SkyPortal. And so from the platform, you can generate observation plans for multiple instruments. Either you do provide the tiles from the instrument, or given the FOV of the instrument, we can generate tiling. And so you have galaxy targeting and tiling and a bunch of parameters to constrain what you would get from your observation plan. Then you will have, we also have this concept of default observation plans, where similarly to what you would have for the notifications, you can constrain a handful of events for which, if they do pass those criteria, you can automatically generate your plan for your instrument. So that as soon as a human accesses that portal and accesses the event, there's already a plan available with a set of carefully picked parameters, and you can play around with improving that event by creating the coverage by creating some more observation plans. And once those are created, you do have a list that references the parameters that you used, and you can see the timing for that specific event. And then you can even submit it directly to the telescope if that has been implemented within your API class that you define. So for CTF, that's how we trigger most of the time. We generate it through SkyPortal, and we send the event directly to the scheduler. Or there's also an option where, if you do not want to use your in-house Guemopt scheduling, you can also directly send the sky map to another endpoint that your instrument has, where you have your own scheduling system. For each of those events, and that's also the case for sources, we keep a lot of metadata. So basically everything that we find in the GCN notice, we keep it somewhere in the database, and we make it available from these tables where localization can be downloaded. And then we have another feature where you can pick several sky maps and then cross-match them and get a more constrained sky map. So that's some more of the things that we keep from the notices. And we fetch aliases for that event and all of the circulars from TAG-GCN. And again, similarly as what you would have for the sources, you would like to leave comments or files and create these reminders. So here are some numbers of what we have in production. So now, those are from 1 month ago, we have around 200 groups with 360 users, which I would say active on a weekly basis, that's more around 100, not those 360. We have almost 200,000 comments. Some of those are, of course, bot comments. But weirdly enough, the person that has the most comment is not a bot, it's an actual person. And it's something like 20% of this. The filters are the filters that work with our broker. And from those 94, we have 60 different filters that are active. So those are user defined, and that's how they get only the object that they're interested in. And again, the number of spectra, annotation, thumbnails, and all of that good stuff. And also just a percentage of increase to show how in just a few months, this gets bigger and bigger. And that's the main issue that we have, is that the platform has been designed for a certain volume in mind. And as it grows, some of the features that used to work don't work anymore. So you always have to go back to things that already exist. And even if the code is just fine, you can still do better. And there's always room for improvement. That's a survey that we did in May to have an idea of, okay, SkyPortal has an API, it has a front end, but what do people really use? And it's most definitely the front end. And for us, front end is king. And even though our API works as is, and we're making changes to it to make it quicker and quicker on a weekly basis, what we'd like to push forward is the front end, so that the platform is a little more user-friendly and not just made for astronomers that want to be doing their work entirely from it on a daily basis, which is what happens at Caltech. So what do the users think of it? We ran this survey in October to try to know what they thought of it. And I just opened it, and what I had was, I have more comments and thoughts than I have time to write right now, followed by this from one person. There's one of them that says it's good, so that's all that I care about. But the lessons that we've learned are that scaling is very hard. Having an app that works, that does exactly what you want, is one thing, but having it work and do exactly what 100 people want is another thing completely. And again, good code is not good forever. That's the whole thing about scaling. So you want to fix as often as you can, deploy even more often, and there's never enough testing. Even if you have 100% of your code that is tested, very often you design it so that the test does exactly how you would like to use it, but users use your features differently. And we try to monitor performance regularly, so on a daily basis, heading to the Google Cloud Console where everything is deployed, and look at what's the health of the database, of the app, and assess how we can match that with the different user complaints saying, oh, it's slower than usual this morning, or I'm not able to use that feature, this is taking too long. And new and exciting features are great, but simpler features that work are much better. So things that we've been working on this year, aside from all of the multi-messenger stuff that we just had to get done for 04, is a better front end. One thing that we've been exploring is that for most websites, when you open more tabs of that website, you fetch the data again and again from the server. And now we're able to use the front end of the person as some sort of local database where you open 100 tabs, it will fetch most of the data from the existing tabs instead of just hitting the API very often. Automatic triggering with our broker, Korolski, and BTS bot. There's a survey within ZTF called the Bright Transient Survey that tries to look at, it's in its name, bright transients, so mostly supernova. And what we've been building is a classifier that tells you if this transient is likely to become a transient of interest for that survey. And now this is deployed with fully automatic triggering, meaning that we get the observation from the instrument, we get the images, we get the alerts, we run the classifiers on them, and then through our broker and SkyPortal, it triggers the instrument, gets the spectra, and the instrument is able to run another classifier to say if it's an SN1A, and then send the classification back to TNS. So we had, I think 1 month ago, we had the first transient that was fully classified 100% automatically without any human in the loop. And as I mentioned earlier, trying to make heavier analysis products that are tough to run locally for most, and even to just fetch the data, trying to bridge that gap and make it available through our instance, which should be available in 1 or 2 weeks. And revamp a lot of the front end, which first starts with new photometry and spectral plots. And it's not the case here, but for the people that use it at Caltech, they know that the packages that we've been using 5 years ago that were great, they're not as well maintained anymore. And so you have to just often redo some of the features that you have from the ground up with something completely different because of those constraints. And speed overall, again, as the database scales, the system scales, the number of user scales, you want things to run quicker than the user. The thing that we'll be working on is a new version of the front end. So we're trying to redo most of it, actually, especially from the styling and making it light enough that it loads quickly, and that also it doesn't hit the server as much. And also we'd like to integrate it with Astro-COLIBRI, because though we do have a front end for the desktop, it's not great for the mobile version of it, where Astro-COLIBRI clearly has something that is robust there and public facing, which is also important, and increase the performance in general. So for the integration with Astro-COLIBRI, there's many things that we could imagine. So I was chatting with Fabian, and so some of them that we could do is connect to a SkyPortal account from Astro-COLIBRI so that you could access your SkyPortal data from the platform. So that could be running consearches to use SkyPortal as a sort of catalog. So all of the objects that humans have been scanning and saving and putting time and effort in could be made accessible for those that have a SkyPortal token through the platform. And also maybe why not import facility data so that then you could use it for the tiling with TilePy. And within SkyPortal, add all of the code that we need to make that possible, but also link it to your Astro-COLIBRI account, and why not do the opposite, fetch data back from Astro-COLIBRI. And one thing that could be interesting is also upload transients from these public data streams that have been scanned for, and are interesting streams that could be object that the community would like to look at. So the team, it's a handful of people, though there's a difference between the people here and those that actually code things. So it's just very few people that do code things, and way more alumni than listed here. And we're trying to get a team of 6 web development students plus 6 web design students that we've been meeting regularly with, that we hope will make all the improvements that we mentioned for the front end to kind of modernize the platform. There's a paper that has been published a few months back that details all of this, though we already made a lot of progress and changes since then. But yeah, if you want to read a somewhat technical 18 pages paper, have fun. So most of those lessons I already mentioned it, so I can skip it. It's open source, so if you're interested in contributing, deploying it for yourself, for your own collaboration or a group of people, it's accessible. You can download it and start as soon as you want. And for those that have access to it through any collaboration or just want to deploy it, there's a lot of resources to learn how to do so. So there's a website, there's a YouTube channel with tutorials, and you can always just ask the questions or open issues on GitHub. Email me, and most importantly, asking me questions today. So thank you for your time.